Take two. Hey, for Elbin team, I'm going to be showing you how to, or some of the various methods of aligning these beams to this surface. As you can see, we have this sloped kind of diagonally like this, so I'll call this a two-directional slope. And the idea is that there are three separate ways of doing this, and I'll show you each of the three ways. So the first way, and I think the simplest way, is going to be to simply select all of your girders. So ignore everything that's not your girders. And the girders have a parameter called the start and end attachments. Change those to distance. And what that's doing is it's affecting the distance that these are from the top of the columns that they are connected to. So I select our columns, attach top. So that is a pretty simple solution. It only will work if your columns are attached, or if your girders are attached to the columns. If you're trying to do, say, a cantilever or something like that, I suppose you could create a column, a temporary column, and then delete it out later. It's not a method that I typically use, but it is a possibility. The other way is going to be by creating a work plane. I'm going to go ahead and go into this. I'm going to create an elevation, which I thought I had. No elevations. Create an elevation here. Sorry, give me a little bit of leeway. We'll make sure we can see everything, and then go to our elevation. Let's go ahead and switch this. So here we go. In this case, you can see the problem is with our elevation is that if we create a reference plane, which is going to be perpendicular to the view that we're looking from, we don't actually have a elevation through the slab surface that will be absolutely perpendicular. I'm imagining in this scenario that the slab surface provided was from some kind of architectural mass model, and they didn't give us exact dimensions on it or exact slope information. So I'll show you two ways of doing this. The first one, we are just going to go ahead and create a new reference plane, and we're just going to match that. And name our plane. So this is how we would be doing it if it were just a 2D slope. And then go ahead and select that plane. And let's expand it so we can see it better. So in the case that we did have just a 2D slope, what I'm going to go back to do is take these. This is all four columns, right? We're going to do an attach top base, well, attach top, and attach that to the roof. They're all attached. And you can see, because the girders are still set to end elevation and end elevation on the elevation attachment types, they stay where they are, as opposed to this one. That's okay, that's kind of what we wanted. In this case, we are going to be deleting all of the girders in the beam systems, and we have to redraw them on this. So let's go ahead and do that. Find our view. We'll do a create similar. Find our reference plane. Now, it's somewhat frustrating because it doesn't always snap where we would think it would. But that's okay, because we just need to get pretty close. Now, if you can see this in this view, go ahead and delete these tags, and then we'll select our beam system and do a create similar. Change our beam direction. So now let's go back to our 3D view, and as you can see, we've created it just as we kind of would have expected. Oops, this one. Oh, right. That is supposed to be there because, as we were saying, we put that on a 2D plane. So, as you can see, that worked, and that's how we would do it on a 2D plane. The advantage of this is that if we go back to our elevation, when we change this, for some reason, say they tried to move it down 1 foot, everything on that plane will be affected as such. So, back to 3D. Right. However, as we were pointing out before, we can't actually do 2 directions unless we figure out the exact slope and then have a cut through there to draw our reference plane, because it can only be perpendicular to the camera, which is, yes, rather frustrating. So, the other option, this is getting slightly more complex. Go ahead and delete all of these. And then we have a Dynamo script. So, Dynamo player over here, and it's called reference plane from surface. We're going to go ahead and run that. So, just like most of our other scripts, select your faces, you have to name it something like roof 2, and set the value, right? So, we don't see anything because reference planes don't appear in 3D. They also, if we go back to our elevation, won't appear here either. They won't appear in the project at all, but we do know that they exist. So, that's a very, I think it's a strange concept to have an element within Revit that never appears in any view, but exists. We'll just have to remember that it exists. We did name it Roof 2, so that's going to be the one thing that we really want from this. As I was saying, we're going to go back to our roof, and as before, we are going to do that, but we're going to change our reference to Roof 2. So this is the sloped version of it. And then, as before, select these, we're going to do a create similar. Now, it doesn't really like it, but it will work, so do that to roof. We'll do it like that. We're just going to draw it out. Boop, boop, boop. And set the beam direction. So as you can see, it's created those. Let's go back to our 3D view. It created them how we wanted to, and kind of as we expected. And the nice thing about this is that now they match that slope because the plane is that slope. Unfortunately, if this top surface were to move, say, up 1 foot, these will stay, but we don't have a way of easily selecting the reference plane that is following this slope, because there is no view that it can be clicked on. There's a Dynamo script for selecting reference planes by names, which I made for this scenario. I generally also don't prefer to do it this way because of that, but it does work. So yes, that is an option. This is probably the most robust option. And then the last option is just using our align beams vertical script. So for these, I'm not positive about this, but I prefer to remove the beam system beforehand. And then we'll just go ahead, select our beams, go into our Dynamo player, and it's called beams align to face. And we select our face, we select our beams, and we align it, which gives pretty much our expected results. We'll go ahead and do an attach. It's, as I was saying, pretty similar. If in this scenario, let's go back to the front. This was raised 1 foot. All these would, again, stay the same, but we can simply run the script again, and it should give us the results that we expect. So, select face, select our beams. Oh, shoot. I just broke it. If this happens, hit continue. Don't quit, because I'll just close out of Revit. And it'll say complete with errors. Sorry. Don't hit quit, because I'll just close all of Revit and you'll lose everything that you've done. Continue is fine. So, sorry. Pretend that that last 30 seconds didn't happen. Select face, and always hit finish up here before you click on the next one. Try not to get ahead of ourselves. So beams, select the beams, finish, align. So the reason why I use this script a lot is just because it's a lot simpler to make quick changes like such. And then the other thing that I was going to say is that, let's go ahead and move this back down. This is just to illustrate a point. If we go ahead and close this out and go to our overhead view, and we're going to create a section. Let's go ahead and go to that section. I'll have this a little bit higher just so I can see. So when we do it as these with the end attachments, it won't match up the slope of the beams. They're always just going to be aligned vertically to how we drew them, if that makes sense. So you can see there's a bit of intersection here. When we do it in the with the work plane, it will always stay aligned because the work plane is in line with the plane that we chose, considering we made the work plane from that plane. And same for doing it from this script. Ooh, it's actually slightly off. So, like I was saying, I think the work plane is the most robust and will always work. It's just the hardest to work with. My script is close, but not perfect. But at least the rotation should be the same. What do we have? 11.43 and oh well, this will have no rotation. So you can kind of see the difference there. Is this is no rotation and this is with that. So it's kind of changing a little bit about it, but those are our options. And be safe with them. Okay, I hope that is somewhat explanatory. always Skype me or give me a call if you have any questions about doing this process. And especially depending on the scenario, we should discuss on what makes the most sense. Because some things are easier if you have to update it a lot. I prefer to use this. If you know that a lot of things, well, we'll discuss later. There's a lot of things to consider. Anyway, I hope that helps, and bye.